All right. So yeah, I just discovered that I mute myself the time I began. So since now I've unmuted myself, let me now just restart everything. I was saying we did definitions and set operations and set algebra is what we're going to do today. Yeah. So let's start. So these are the things that we're going to look at today, and I believe most of us now are able to hear me. You are all able to get me because I can see here my microphone is on. All right. So today we're going to focus much on proving and simplifying sets because we did laws of sets and proving of Demogan's laws using element methods. I mean, we only touched part of Demogan's laws. Today we're going to be proving it. Yeah, so let us look at this example here, which is saying let x and y be any sets. So x and y are any two sets. So just imagine x to be a set and y to be another set. And then the question is saying simplify x complement intersection y union x complement. So when you're solving these questions, you need to have all the rules of sets. If you went through the slide which I circulated yesterday, these questions are going to be easier and simple for you guys. Yeah. So let us now let us now do this one here. So I'm going to start with this one. So I'm saying x complement intersection y union x complement. So the first thing that we do here, remember I said sets are also mathematics, hence they obey the what, the rules that yeah, the rules of body mass, they obey those rules. Yeah. So we first have to deal with what is in the brackets before we deal with what is outside. So let us first look at inside there, we deal with them. So from what is inside there, you can agree with me that inside here, if I want, I can use distributive law. Yeah. So I can just distribute what is inside there after distributing them, and then I'll apply the complement. And then other ways I can do this, I can first apply the complement and then distribute what is inside. But the easiest way is first to distribute what is inside there. So this x union will be combined with that x complement. So x union x complement, we combine them here. So I'm going to say x complement, then we have that union, and then this x there. I'll put them in brackets like that. Yeah, so don't mind my handwriting. It's been long since I solved mathematics using this mouse. Then we move on. So I'll get this x again, combine it with y, and then which sign is going to be in between is this one here. So this is the sign that is going to be in between. So I'll put intersection there, and then I'll say open brackets, and then I'll write this x union, or I can start with y, there's no problem. I can say y, and then I'll put the union there, and then I'll put the x. But what you should not forget is that everything here is under this complement, which is there. There's this dark thing here, which is a complement. All right, so we proceed. And from the rules that we learned, you can agree with me that x complement union x is nothing but the universal set. So the universal set intersection x, intersection y. Let me write it the way it is. We're saying intersection y, and then we have the union there, x. Then we put in brackets Of course, don't forget to put the complement outside. Hope you are all able to see what I'm writing. And then this universal set here. Universal set intersection any set, it is just that set. Same as me saying A intersection universal set. It is just that same set. So in this case, when we say this universal set intersection, this set here will just remain with this same set here. Hence, we're going to have Y union X. Then don't forget to put these brackets, and then there's that complement outside. And then using Demogan's law, now you can distribute this complement there. And then whenever you're distributing a complement, the sign always changes in between here. So we're going to have Y complement. Instead of union, it's going to be intersection X complement. So this is the solution for the first part of the question. X, Y complement intersection, X complement. It is just as simple as this, simple as drinking water. So let us look at the next question there. So the next question, or first, what is here is the solution. Yeah, you can see here, I provided the solution for the first question there. Let us now also take a look at question B, which is saying X intersection Y, saying X intersection Y, then everything in brackets, and then we have union in between, and then we have open brackets. This X minus Y is the set difference. The difference of two sets can also be written as X. Instead of putting a minus there, I'll put intersection, and then instead of putting Y, just Y there, I'll put Y complement. So this X minus Y can also be written as X intersection Y complement. So here, as you can see, we have this common, we have also this common. We can factor, instead of distributing in this case, we are now going to factorize. Yeah, so remember what I told you, sets are just like any other type of mathematics, all the rules apply. So we factorize X intersection, even this side X intersection. So I'm going to factorize X intersection. Then what am I going to remain with? Here, when I remove X intersection, I'll just remain with Y. And then I'll write this union symbol. And then we have this Y complement there. Yeah, in the second part there, when you remove the X intersection, you just remain with Y complement. And then remember, when we say Y union Y complement, what is the answer? Y union Y complement is nothing but the universal set. And then remember what I said, any set X intersection the universal set, I said it's just that same set. So when we say X intersection U, it's just that same X. Yes, hope this is clear. I hope this is clear. Let us proceed. Yeah, so this is just the solution for the second question here. And then question 2. Question 2 is saying if A is equal to that and B is equal to that, find the following sets. So if A is equal to this and then B is equal to that, find the following sets. A minus B. So I'll start with A there, which is saying A minus B, like that. Okay. So when I say A minus B, this A minus B is nothing but equal to A intersection B complement. So A minus B is just the same as A intersection B complement. So meaning we're going to we're going to look for the common elements which are in B complement and in A. But in other words, if you want this to be simple for you, you just say list the elements that are in A, excluding the elements that are in B. I don't know if that statement is clear to you. List the elements that are in A, excluding the elements that are in B. If you can't master this statement, which I've said, just follow this same expression here. You list A, you also list B complement. When you list B complement and then you also list A and then find the intersection of the two sets, you're going to find the answer. So for me, the simplest way I know how to solve this is just by listing A, and then I'm going to delete all the elements that are common in A and in B. So do we have 2 here? We don't have. Do we have 4? We don't. 5? We don't. 7? I can see 7 there. There's also 7 there. I can see 13 there. So I'm cancelling this 13. I'm also cancelling that 13. So I'm going to list this set A, excluding the common elements. So this is 2. Then we have 4. Then we have 5. Then we have 10. Yes. So A minus B is just the same as A intersection B complement. So A intersection B complement is just equal to this. Yeah. So this is our first part. We're not going to delete this because I know this may be helpful. It may help us to answer this question here. So let us now move on to B. So B is saying B minus A. So now this is now B minus A instead of A minus B. So in this case, we're going to list B and then excluding the elements that are in A and B. So what am I trying to say in other words? I'm trying to say that we're going to write the set B intersection. Let me just write this properly. So I'm going to write B intersection A complement. So B intersection A complement is what we are going to list as our set. And then I said I'm going to write the elements in B excluding those that are common. So in short, I'm just going to list B excluding these ones that I've cancelled. So I'm going to write 1, then we have 19, and then we have 20. All right, so this is B minus A. So this is my B minus A. So after finding B minus A, let us now see how you find C, this one here. So C is saying A, then we have a triangle in between there. Then we have B. How do you calculate such a equation? So this one we know to say, if you want to find the solution for this, you just say A minus B and then union. You find the universal set of A minus B union, A minus B and B minus A. So when you combine the two sets, this one, when you combine this set and that set, you come up with a triangle B. Yes. So I'm not going to finish up this one because I think I've written it. It's at the end. It's one of your exercises. Yeah. So let's proceed. Let's see what is here. Question 3 is saying let x and y be any sets. Simplify x complement union y and intersection what? X. Then there's a complement outside. I think we've solved a similar question as this. The first question that we solved was looking like this. So for the sake of just revision and clarification, for those that did not understand, I'll do it again. So I said there are two ways in which you can solve this question. If you want, you can start by distributing the complement which is outside, or if you want, you can start first by distributing this x inside, x intersection inside. So if I distribute the x intersection inside, I'm going to have x intersection times x complement there. I'm going to have x complement intersection x, and then I'll put them in brackets. And then I put this u there, and then I'll distribute this x intersection to y again. So I'm going to write y, and then there's this intersection, then we have that x there. And don't forget to put the complement. So here what you just need to do again, remember what I said about this expression here. X complement intersection x, this one is an empty set. Why do I say it's an empty set? You try to find the common elements between what is in x and what is not in x. It's nothing. Yeah. So it's an empty set. Then you have u, open brackets. Then you have y intersection x. Then you put your complement outside like that. So this empty set union y intersection x. So when you find the union of, or when you combine an empty set to any set, you still get that same set. What am I trying to say? It's like I'm taking nothing and adding them to something. I'll just remain with that thing. In other words, maybe, let me give a practical example. If I get maybe one pen, and then I add nothing to that pen, I'll still remain with that same pen. Yeah, this is what it means. An empty set union y intersection x, I'll just remain with this same y intersection x. But of course, don't forget to put the complement there. So y intersection x complement there, when you distribute using Demogan'S, you're going to have y complement, the sign on the middle will change, and then you also have x complement this side. All right. B is part of your exercise, so I'm not going to answer it. C is exactly the first question that we solved. And then let's now move on to D. So D is saying x union empty set. This is what I'm just talking about here. You get x, you add it to nothing, because the addition of two sets is union. So when you get x and then you add it to nothing, you still remain with the same x. Here, when you get x and then you find the common elements between x and nothing, you are going to have nothing as your answer. It's like you're trying to find what is common between nothing and something, you just remain with that thing. There is nothing, I mean, you just remain with, you find nothing in short. And then X intersection nothing complement, intersection empty set complement. So the empty set complement is just equal to the universal set. So here, in other words, they are saying find the value of X intersection universal set. So X intersection universal set, you discover that your answer is going to be X. When you combine, I mean, when you find common elements between X and the universal set, meaning in the universal set, we also have the same X. Whenever you have the universal set, you also have that set. For that set to be called universal, it means that it composes or it comprises of all the elements that are in those given sets. So here what we're just going to have is X. And then universal set complement is just the opposite of this statement. Universal set complement will give you an empty set. So universal set complement will give you an empty set. So here what they are trying to say is find an empty set intersection Y. And of course you get an empty set because this one here is just the same as this. Only the letters have changed and they've switched the position of the letters. Okay. Let us now look at one very important part of sets, which normally confuses a lot of people. And these are intervals. A lot of people get confused when they see intervals. Yeah. They think they've seen hell when it's heaven. All right. Let us look at the intervals, the interval notations of sets. So when you see these kinds of brackets, these means inclusive. So these kinds of brackets means inclusive. So if I write A, comma, B in these kinds of brackets, it means that, oh sorry, this simply means that A and B are not part of the set. They don't mean inclusive, sorry, I just said the opposite. The ones that mean inclusive are these. So like when you look at this statement here, the first part here, A comma B, and then they're in these kinds of brackets, it simply means that A and B are not part of this set. We're only talking about real numbers that are in between A and B. So meaning when you look at these kinds of brackets here, just know to say A and B are not part of the set. But if you see these brackets like this one here, it simply means that A and B are part of the set. So the same applies when I say 1, 2 here. If I told you to count the numbers between 1 and 2, you can't manage. No matter how clever you are, no matter how good you are at mathematics, you can't. Because the numbers that are here, they're a lot. I don't know if I can say there are millions of numbers or trillions of numbers between 1 and 2. But what you should know is that you can't manage to count. That's the reason why when we're dealing with these kinds of brackets, just know that we're talking about real numbers. And the shortest or simplest definition of real numbers is that it is just a set of numbers. I mean, it is just a set of all rational and irrational numbers. So when we talk about rational numbers, we're talking about fractions and these other numbers, all numbers. But when you talk about irrational numbers are square roots, are what and everything. We have all those between 1 and 2. So I mean, you can't manage to count numbers between 1 and 2. But what you should know is that when you have these kinds of brackets, the square brackets, they simply mean the numbers that are there are inclusive, meaning they are also part of the set. But if you have these kinds of brackets, they simply mean the numbers, rather the elements that are inside there, they are not part of the set. Okay. So this one simply means not part of the set, then this one part of the set. So if we were to draw a number line for A and B for this one here, we can draw it like this. Okay, a number line always needs to have a 0 somewhere. And then if my A is here, then my B is also there. Come to draw this, I'm going to put an open circle there, and also on B I'll put an open circle. Yes, but if I'm drawing a number line for this one, let me just draw it quickly. I'll do this A, and then I'll do that B. So here on A it's going to be open, and then there on B it's going to be closed. Why am I closing at B? I'm trying to show you to say B is part of my set, but A, since it's open at A, then A is not part of my set. Okay? Same applies to this one. A is part of the set, B is not. Here both letters are part of the set. And then when you look at this one, A is not part of the set. And then we're just remaining with 10 minutes. Yeah, so A is not part of the set. So we're talking about numbers greater than A. Yes, so if we're dealing with set builder notation here, we can write it as A greater than, X, sorry, I was supposed to start with X. We're talking about numbers to say these numbers, or X is representing numbers. So we're saying this X is going to be great. We're using S, sorry, not X. Yeah, so we're going to say X is greater than A. Let me just erase this and write it proper. So if we're using set builder notation, we can say these numbers X, these numbers denoted by X will be greater than A. Oh, sorry, not greater or equal, but just greater than A. I don't know why I'm making these silly mistakes today. All right. Yeah, so this is in set builder notation for this one. For this first one here, we can say A, and then A is less than X, which is less than B. For the second one here, we can say A is less than X, but less or equal to B. So while there's this kind of bracket here, you put less or equal to. Yeah, you can see there. And then the fourth one there can be written as A less or equal to, since we have the same kind of bracket, which is the square bracket on both. So we're going to say A is less or equal to X, which is less or equal to B. Yes, so this is how you write them. And then this one, instead of you saying negative infinity is less or equal to X, which is less or equal to positive infinity, just not to say we're dealing with real numbers. So instead we just write R there. Anyway, I think I put something in these same notes. You are going to see it for yourself. There are a lot of number lines and everything that will help you understand. Yeah, actually this is what I'm talking about. I know maybe some of you can't see it clearly since you're using phones, but for those who are using laptops, I'm sure you can see the number lines and the set builder notations there at the end. All right, so I'm going to distribute the slide. You're going to see this. You're going to go through it on your own. So let us try to look at an example concerning these same integral notations of sets. Oh, sorry, interval notations of sets, not integral. So question 4, this one I've written it to be question 4. Yeah, for a certain reason, because I want to get something here as an exercise. So given that A is equal to -2, 1, you can, so make sure when you're dealing with such sets, the intervals, take note of the brackets. Look critically on the brackets. What kind of brackets have they used? Okay. So when you look at A here, A is equal to, there's this open bracket and then there's this closed bracket. Yeah, actually I've even remembered clearly now. This one is called an open bracket. This one is called a closed bracket. So 0 here is closed, meaning it's part of, on this one, 0 here is closed, meaning it's part of the set, and then 2 here is open, meaning it's not part of the set. So here, -2 is open, meaning it's not part of the set. And then we have 1 there, which is open, meaning it's part of the set. And then the question is saying, find each of the following sets and show them on the number line. So I'm going to answer A, B, and probably even C. And then you answer D and E as your exercise. So A is saying A intersection B. So A intersection B, how do you find the intersection using intervals? So it depends now on you. If you're sharp enough, you can start with finding the answer and then draw the number line. But if you are slow when it comes to analyzing such, and more especially if you are learning this for the first time, it's better you first draw the number line and then get your solution from the number line. So I'll show you the simplest way, which is by first drawing the number line. But for me, I already even know the answer here, because just by looking at it, I can tell to say this is the final solution. Yeah. So I'm trying to find the intersection A intersection B. So A intersection B, let me write the answer here. A intersection B. What is common here? We have the numbers here ranging from -2 to 1, then from 0 to 2. So meaning if I'm writing my final solution A intersection B, I'm going to start with this. So we can see that here 1, we can see that 0 there is closed, and then between -2 and 1 we have 0. So meaning I'll start with writing 0, and I'll take the bracket that is on 0. The bracket that is on 0 is a closed bracket, and then I'll say comma. And then where am I going to end? Do we have +2 in this, in A? We don't have, but we have +1. Do we have +1 in B? Yes, it's there because it's between 0 and 2. So I'm going to put 1 there, and it's also going to be closed like that. So now let us try to check if we're going to find this same solution using the number line. So I'm going to draw my number line like that, and then I'll put a 0 there. And then this side I'm going up to 2. Of course, these are negatives. And it continues going like that. Time is moving fast, so maybe I'll only manage to answer a few questions here. And then this side we're also moving up to 2. 1, 2. So now I'm going to show A. Let me show A. So when I'm showing A, I'm going to open. So A is open at -2, and then it is closed at +1. So where it is closed, oh sorry, +1, not -1. Sorry. Okay. +1 and not -1. Okay, so it's closed there. And then let us also draw B. So I'm going to draw B. B is closed at 0. So B is closed at 0 and it's open at 2. So I'll draw the straight line joining the 2 points. So if I'm trying to find the intersection is just this part where these two lines are meeting, this part which I'm shading right now. This is the intersection. So the intersection is just ranging from 0 to 1. And how do you know whether it's closed or open? You look at the circles here. Are they shaded or they are open? If they are not shaded, then it's open. Now in this case, they are all shaded, meaning it's closed at 0, it's also closed at 1. So this is the solution you can see. So if you want, you can start with finding this, and then you draw the number line. Or if you want, you can first draw the number line and then find that. Just remaining with 1 minute. Wow. So if I'm to find the universal set B union A, B union A is just a matter of combining the two sets. You start with the lowest this side and then the highest that side. So meaning B union A is just going to be equal to, you get the highest number this side, which is -2, and it's open, and then you say comma, the highest number this side is +2, and it's also open. So this is B union A. Very simple. So you guys, you answer the remaining questions as the exercise due to time. Yeah, so you answer 2C, 3B, 4D, and 4E. So I've